Hi class. Today we're going to be discussing polyatomic ions. Polyatomic ions are a group of covalently bonded atoms. So they share electrons between them. They don't transfer as a metal and a non-metal, but overall they have a charge. So they are covalently bonded to each other. And for hydrogen, it's a duet. So 2, 2, 2, 2. And then nitrogen would have an octet, 2, 4, 6, 8. They share these electrons in order to make that, but overall has a plus charge. So this is an ammonium ion. And it's the only one that actually has, when we're dealing with charges, we're going to be dealing with all negative charged ions. This is the only positive one that we're going to be dealing with here. And this is a +1. These brackets indicate it's overall. It's not on any one of these. It's an overall for this ion. So they often consist of nonmetals. So all of these are nonmetals here. And they're bonded covalently. And the other ones we're going to deal with a lot of bonded to oxygen. But in this one, it's not. It's hydrogens and a nitrogen. And this is a +1 charge. So the rest of them are going to be one of these charges. So this is the only one has a positive charge, and this is ammonium. So this is an ammonium ion. We deal with a lot of polyatomic ions, everything, to make our lives easier. You just probably do not know the chemistry of it, so you don't realize that we're dealing with polyatomic ions. Sulfate here, this is going to be a part of this. Ammonium, this one has 2 polyatomic ions. We have ammonium, which we just looked at, and we have nitrate, and that's fertilizer. Here is a list. To make your life easier, I strongly suggest you learn these. There's a lot of them, but to make your life easier for the rest of the semester, it would be in your best benefit to learn these. Make flashcards if you need to. Spend 5 minutes a day going through them, and after a while, you will start learning these, and you will not struggle as much. Learn it in the beginning because none of this stuff goes away. We just keep building upon it. So let's get started. These are nonmetals, and this is the formula, and here's the name of the ion. The ones in bold are the most common, but in chemistry, we tend to use all of them for when we're learning. So nitrogen has ammonium. We already covered this one. The only one the positive. Oh, sorry, I jumped up. This is an OH. This is called hydroxide. Hydrogen and an oxide. We're going to come back to this because this is part of bases. When we start dealing with acids and bases, this is going to come back. So you will definitely see this one in other chapters. Here we have ammonia, we have nitrate, and we have nitrite. So they begin with the nite, and then they trate and ite, and I'll get into that later about what these mean. With chlorine, we have 4 of them. And there's different names for them. And what you should notice is that this one has 1 oxygen, this has 2 oxygen, this is 3 oxygen, 4 oxygen, but they all have a negative charge. And that negative charge is not on the oxygen, it is on the whole compound. So if we had to draw, it would be in brackets, but we don't draw it. It's just something you have to know. So even the ammonia, it's got a plus charge, it's for the whole compound. So in the beginning, if you need to draw brackets, draw it, but you should know it's on the entire compound. And then we have carbon. We have carbonate. And then this one has a 2 minus with a 3. This one, it gets added with the hydrogen, which changes this charge, but it's still got 3. And then this is cyanide. And this is acetate, which we'll get covered tomorrow. And unfortunately, there's still more you need to learn. With sulfur, we have sulfate. We have now sulfate with a hydrogen, changes the charge on here. So it's either bisulfate or hydrogen sulfate. And then we have sulfite, and then hydrogen sulfite with an added. And then phosphorus goes into phosphate. So this is a 4 with a 3 minus, and then we have a 3 oxygen here. That one's 4, and this one's called phosphite, and then in between. Trust me when I tell you that it will make your life easier to at least make sure that you know the common ones. From the common ones, you can sort of figure out what the other ones are. But if you want to avoid struggling, it makes it easier for you to have this and know it. Okay, so I'm going to go over what all of these mean. This is 8. 8 here means compounds have the most oxygens in them. So if we look at sulfate, you can hear sulfur, that's S. The 8 means 4 oxygens. 4 oxygens, 3 oxygens. Why is this different? Because out of compounds of nitrate and nitrite, this one has 3. So that's why it's given an 8. Phosphate has 4 on here, and phosphite ends in ite. So the compounds that have out of those compounds, now none of these are related to each other, so don't look for things that relate them. Look for the partnership of nitrate and nitrite, phosphate and phosphite, and sulfite, but don't look within each other. There's really nothing linking them except for the 8. So anything with 8 has the most oxygens of that species or compounds. Anything with ite has 1 oxygen less than the 8. So that's why I say if the most common ones here tend to be the 8. Nitrate, chlorate, carbonate, sulfate, and phosphate. 1 less from that is the ite. So sulfate has 4, then that means if you hear sulfite, it has 3. The charges do not change on these. If you know phosphate, phosphate has 4 oxygens and a 3- charge. Phosphite has a 3- charge still. The charges do not change, but the oxygens do. This one has 3. Nitrate has 3 oxygens with a negative charge on the overall. Nitrite has 2. So if you learn the common ones, then you can also understand that if it's an ite, it's 1 less, but the charges themselves do not change. All right, now to make it even more complicated, let's start with carbonate. So this is carbonate right here. It has a -2 charge, but if we add a proton to it, that reduces this charge. So now it's a -1 charge because we added a proton to it. And we also have to change the name. So carbonate by itself is this, but when we add a hydrogen, it's either bicarbonate or hydrogen carbonate. Both of these names work, and you need to know that that's what this is reflective of. Sulfate has a 2- charge and 4 oxygens. You add a proton to it, and it is now a -1 charge instead of 2, and it's either bisulfate or hydrogen sulfate. And then we get into, these tend to be halogens here. This one's chlorine. So we have 1 oxygen, 2 oxygen, 3 oxygen, 4. The naming of it tells you what you're dealing with. So let's pick this one here. We have chlorate. I picked the wrong one, but we have chlorate. Chlorate means most oxygens. So this is 3. Chlorite, if you know that this is 3, chlorite has to be 2. But what if you get per or hypo in front of it? So with this case, if you have chlorate and then you hear perchlorate, what that means is it's actually 1 more oxygen. It's a 4. The per in front of it adds another oxygen. And then if you have chlorite and you hear hypo, that means 1 more oxygen taken away. So if you're hypochlorite, this is 1 oxygen. Chlorite is 2 oxygens. Chlorate is 3 and perchlorate is 4. These are all compounds with the same charge, just different oxygen number of oxygens with it. So how do you write these? This is the book's way. I'm going to show you what the book does, and then I'm going to show you my way. So you're given magnesium nitrate. This is why you need to know them, because you're not going to be given any more information except for nitrate. So you would have to look it up. And if you just know it, you automatically remove all of that from you, the stress. So we need to put this in a chemical formula. So magnesium is a 2+, and nitrate, you're going to need 2 of them in order to balance out this 2 charge. If you do the math, that tells you that. Now add them together. So you have a 2 and 2. So this one means that you have to use a parentheses. For when you're dealing with polyatomic ions, you have to use a parentheses in a chemical formula if it requires 2 of them or more. If it's 1, then you don't need to worry about it. But if it's 2, you have to put a parentheses. That parentheses is reflective of the fact that that polyatomic ion has to stay intact together. And then the 2 or 3 or 4, how many there are, has to be on the outside to show that there are 2 nitrates, not just 2 oxygens or 2 nitrogens. It's got to be for the whole compound. You have to use parentheses. And it has to be around the whole thing. This is another reason why learning polyatomic ions, you will instantly know that the parentheses has to go around the whole thing. So that's how the book does it. I'm going to show you my way. Make sure you know the nitrate. This is the whole compound. This is magnesium. Crisscross them. Nothing changes except for you add a parentheses to indicate that there's 2 of this whole compound. And that would be a 1, and there would be a 1 there. Okay, so let's do some exercises to help you understand this. Write the formula for aluminum bicarbonate. So the first thing you're going to do is you're going to have to break this up into the charges of what they are. So we have aluminum, which is 3. It's in group 3, so it's got a 3 plus. And now we have bicarbonate. Bicarbonate, the fact that it says bi in front of it or a hydrogen means there's a hydrogen in front of it. So hydrogen carbonate or bicarbonate means the same thing. It went from a carbonate, so if you block this out, it's carbonate, but you have to add a hydrogen in front, which changes the charge on it. Now crisscross them. Because there are 3, you have to put the parentheses around the whole thing. That has to be shown that this 3 accounts that there are 3 hydrogen carbonates with this aluminum. Okay, let's do another one. Sodium phosphate. So here's the phosphate ion. Now we're going to crisscross them and then use parentheses if we need to show that the compound will stay intact. So here we go. We have the 3. The 3 will go here. The phosphate will go here. There's parentheses, but in this case, you don't need a parentheses because there's not more than 1 needed. So you can actually write it like this. It only needs parentheses if you have more than 1, so you have to account for it. Okay, so naming ionic compounds containing polyatomic ions. When naming an ionic compound containing polyatomic ions, you first write the positive ion, which we've been doing if you have been following the previous my lectures, and then you write the name of the polyatomic ion second. Recognizing polyatomic, now this only applies to the negative. I haven't covered the ammonium on here. And I don't think it's up here, but ammonium is a positive, so that's the only case that this would be different. You would name ammonium first, and then whatever was with it, ammonium chloride, ammonium oxide, and so forth. So you follow that the same way. It's positive, you leave it, and then you add whatever's at the end with the "ide" ending. So here, we're just going to deal with negatives. You're given Na2SO4. Once you realize that you can determine what the polyatomic ion is, you can name it. This is sodium sulfate. It follows the same naming as ionic compounds. We don't reflect that the subscripts say how many. It's just sodium sulfate. The 2 charge goes down, and that's how you see it. Phosphate. Here's the phosphate. So this one's tricky because of the fact that you're going to have to know that this phosphate has a 3 charge, because you're looking at iron and there's nothing here. So these are those ones I'm talking about. You have to know what the charges are. This has a 3 charge. There should be a 3 on this side if it's crisscross. The fact that there's not a 3 here tells me that this is iron 3 and it was reduced down. So this is iron 3 phosphate. The writing of it, the actual writing it out, the name, will always tell you what oxidation state it is. But when you write in chemical formulas, we reduce those down. So this may not always be reflective of what the actual name is, and you have to know that it's been reduced down. And then we have carbonate. Carbonate has a 2 negative charge. Aluminum has a 3 plus charge. So we're going to have to do some crisscross with numbers on both of them and make sure that they are appropriate for how it needs to be written out. So aluminum has 3. So we need to make sure there's a parentheses around the whole compound. And then the 2 goes around aluminum. So this is aluminum carbonate. Okay, so let's do some examples, some problems. Aluminum nitrate. Nitrate is here. I added it so you can see it. And now we know that the parentheses has got to go around the whole thing if it's more than one. Aluminum has 3. So we need something that's going to be in parentheses, and a 3 has to be on the outside. But now look at, there's a 3 on the inside. So we're looking for a 3 on the inside and a 3 on the outside. This doesn't have anything to it. This is incorrect because aluminum has 3 plus to it. This one is incorrect because the oxygen has no 3 on it. And this one is correct because there's a 3 oxygen on the outside and there's a 3 outside the parentheses to show the whole compound is included. There's 3 of the whole compounds and not just the oxygen. Copper 2 nitrate. So again, this would be copper 2 plus. Nitrate is this. So we're going to look, this is 1. So we can't look at the 1. What we need to look at is the 2 that would be around the nitrate. So there's got to be a parentheses there. So let's take a look. This one does not have a 2 on the outside with parentheses. This is wrong. This one has a copper, has a parentheses around the nitrate, and a 2 on the outside. This would be the correct one, but let's take a look at why this one would not be. This one would not be because 1, there's no 2 on the outside of this one because you've got a crisscross, so 2 should be outside the nitrate, and it's outside the copper. Nitrate does not have a 2 minus, it's got only a 1. So this one is showing wrong oxidation state. So this would be B. Iron 3 hydroxide. So here is hydroxide. It's got a -1 charge. So we're not going to be able to look at that on here. We're going to need to look at for the iron 3. So this is going to be Fe3 plus and then OH minus, and we crisscross. So I am looking for a 3 and a parentheses around hydroxide. So this one is wrong. This is 1-to-1 and it's not reduced down because this has to have a 3 minus charge for it to be reduced down. This one has a 3, but it's still in the iron, which is wrong because that's then crisscrossing stain again. This is the 3 minus. Here's the parentheses with 3 on the outside. This is correct, C. And now we have tin 4 hydroxide. So this one, it can be a little tricky. So if we look here, we have it would be SN4, and then hydroxide has a -1. So what we're looking for is something that has a parentheses and a 4 on the outside, and here it is. We have 4 and a hydroxide. This shows the hydroxide is intact, and we need a 4 on the outside of it. The rest of them this is a 2, but there's nothing to reduce it down. So this is not correct because that means that this would have to have a 4 charge to reduce this down with a 2 showing. Or the oxidation has to be 2, and it's not, it's 4. This one is keeping the oxidation still on this, which means this would have to be -4, and it's not. So here are the correct answers. I went through them. Hopefully that makes sense what I'm showing. These chapters get harder. So spend time, go through my lecture, write the best notes that you can, look at the naming, memorize, and learn the polyatomic ions. You will make it harder on yourself if you do not do these things. And then here's a flow chart, just understanding some of what we've covered. Here's ionic, metal, non-metal. It's either a metal or ammonium. That's the plus. And then it kind of gives you a little chart to understand what you need to do. If you get stuck, try looking at this chart to see if it can get you to understand. We haven't really covered molecular. So right now we're strictly on these. Polyatomic ions, monoatomic. Monoatomic means 1 atom. And so these are more than, this is poly, that means many. This is 1. So this would be, a nonmetal is something like chloride, oxide. Yes, it has a 2 plus charge, but it's 1 atom by itself. Okay, now let's keep going on. We have name the following ionic compounds. Because you don't know these, and I didn't put it on this one, but this is nitrate. Hopefully this is looking familiar to by now. The 3, this is nitrate. Calcium, crisscross this out. So this would be, I think I didn't put them together. Oh, I did. Okay, that's fine. So let's break it down. This is calcium with a 2 plus charge. Nitrate has a -1. Name the cation. Calcium. Name the anion. Nitrate. Put it together. Calcium nitrate. Second one, we have FePO4. There are no numbers here. So that tells you that either iron has an oxidation state of 1, or it's been reduced down. How will you know that? Because if you know what phosphate, the charge that goes with phosphate, this will help you determine what's going on. So here we have a 3 plus, we have a 3 minus. So this means that this is iron 3, no space in between, and this is phosphate. So these were actually reduced down. That's why it looks like this. And the name is iron 3 phosphate. Okay, we have some more. So let's take a look at what we have here. I think I broke it down the same way. Let's make it easier to look at. Magnesium has a 2 plus. This is a 3. Sulfate has 4. So this is one less. This has to be sulfite. So this is magnesium sulfite. And there's the name. Next one is magnesium. It has a 4. So same thing. We're going to go through. Notice there's no 2 here or 2 here. This has been reduced down. So that's why there's also no parentheses on these. So when things get reduced down, they make it harder to understand. This is why you have to learn some of the oxidation states for these elements, or you will pick wrong answers. So magnesium is a group 2. So you should instantly look for 2. If it's not there, because you've also learned sulfate, you know it has a 2 minus. That's why it's reduced. So this is magnesium sulfate. Now here is one that looks like it's difficult, but again, if you have learned the phosphate, then it's not as bad, or phosphite, excuse me. This is a 3, not a 4. So it is P, 3 oxygens and a 3 minus. So this is phosphite. This is lead with a 2 on it, so we crisscross, and this is lead 2. So lead 2 and then phosphite, so lead to phosphite. These may seem overwhelming, but honestly, they get repetitive, and the more you start looking at them, you'll start to see that we use the same ones over and over again, or the endings are the same for this and the endings are the same for that. And you'll start seeing this and it won't seem so overwhelming as long as you make the effort to keep trying, looking over, reading everything, looking at the lectures, doing the homework. There is so much out there that you can help you to learn. Make flashcards. If you make flashcards, yeah, it makes an effort, but in the end, you're not struggling with this. All right, and let's do, I think this is the last practices. So here, crisscross again. I think I have it broken down. I do. So we have iron crisscross 3. Sulfate is a 2 minus. So it's iron 3 sulfate. This is barium. Barium is a group 2, so it has a 2. And then phosphite, 3 oxygens. So this is barium. Barium is a group 2, so we don't use oxidation states. It's not a transition metal. Barium phosphite. And then we have nickel. Nickel is a transition metal, and it's got a 2 plus, and it's got a 3 here. So this is carbonate, so 2 minus. Now the book has this listed as nickel 2 carbonate. Oh, actually, no, this is right. I was thinking it was one that only had 1 oxidation state, but it's not. So here is nickel 2, representative of this, and carbonate, nickel 2 carbonate. Do you notice that there's no 2? That's because there's a 2 here and a 2 here. Bring them down, they would be reduced out. And that's it. Thank you.